Hello, my name is David Stevens, and I'm a Senior Technical Solutions Consultant at Entrust in the Data Protection Solutions Group for HITRUST products. Today, I'm going to talk about how to add a protective layer around your VMware infrastructure by utilizing a combination of Entrust, formerly HITRUST products, to accomplish this task and why. As you can see from this slide, Entrust has acquired HITRUST. This happened back in January of 2021. Those familiar with HITRUST and our products have nothing to fret about. The HITRUST product line is sticking around. In fact, the HITRUST products will be enhanced and take on more prominent roles alongside the Entrust product lines. Over the next few months, the HITRUST products will be rebranded and you will see a facelift of the user interfaces. It's no secret that data and infrastructure breaches continue to occur. And as recent news will attest concerning the vast Solargate hack, things don't seem to be getting better. Many of these breaches occurred because of compromised credentials. Without proper automation and rule sets in place, I think the answer is clear: it will get worse. This is one of the many reasons why using multiple layers to protect your VMware infrastructure is so important. Traditionally, VMware virtualization groups have relied on the network as one of the primary layers for protecting their VMware infrastructure. This includes load balancers, network firewalls, and microsegmentation of the network. However, the network shouldn't be the only layer that you should utilize. The bad guys will eventually figure out a way to get around it. Using Entrust, private, public, and government IT groups can provide extra layers around their VMware virtual infrastructure, knowing that critical applications and data are secure. The Entrust Security Policy Framework helps organizations to limit the risk of privileged admins with robust role-based access controls to include secondary approval and multi-factor authentication. Protect data through encryption and centralized key management, enforce security policies around the workload and maintain compliance through automation. Entrust helps fulfill agile and cost-effective workload protection requirements, preventing unauthorized communications, preventing unauthorized access, and logging all administrative activity. Entrust Cloud Control is the backbone of the Security Policy Framework and is the robust extra layer needed to protect your VMware infrastructure better. Cloud Control enables the first additional security layer along with the usual username and password by validating privileged user access requests made through the transparent proxy. Supported access request methods are Active Directory or multi-factor solutions that already exist in the customer environment, such as Entrust Identity as a Service, RSA Secure ID, or radius-based authentication mechanisms. Two core tenets of security are the principle of least privilege and separation of duties. Cloud Control accomplishes both of these through the use of role-based access controls and secondary approval workflows. Secondary approval workflows allow organizations to have greater control over the use of powerful administrative privileges by forcing virtual administrators to acquire an additional level of approval to complete a sensitive operation that could be detrimental to the virtual infrastructure if performed on the wrong day or time. An example would be powering off a critical VM workload during business hours. Role-based access control and secondary approval workflows also enable an organization to better understand and monitor admin privileges, thus helping them to determine current risk profiles and adjust permissions accordingly. Hopefully you see that the additional security layers provided by Cloud Control enhance existing network-based security for your VMware infrastructure. A strong password is a crucial defense to protecting digital identities. High-assurance credentials create secure digital identities backed by public key infrastructure to facilitate secure access, email encryption, and digital signing. We are the first among security providers to develop a passwordless solution using high-assurance credentials to protect workforce identities and corporate data. The solution works with a certificate authority of your choice to issue digital credentials at scale. There are multiple benefits of creating trusted digital identities. The solution is highly scalable. This high-assurance solution works with multiple applications and can be deployed on customer platforms or embedded in customer applications. It can be used on mobile devices, thus virtually eliminating passwords from the authentication process. We aim to provide an enhanced user experience by removing the friction caused by passwords and use the power of the underlying public key infrastructure to strengthen the security posture. For more information on Entrust Identity as a Service and other Entrust as a Service products, be sure to sign up and watch our presentation titled Delivering Trust, Innovation, and Agility with Entrust as a Service. Entrust Cloud Control operates as a transparent proxy that seamlessly intercepts, monitors, enforces, and logs all privileged user requests originating from various access mechanisms, including the VMware vCenter client, SSH, and any tools that utilize the vSphere APIs. You deploy the Cloud Control Transparent Proxy in a highly available active-passive pair of virtual appliances. If the primary/active appliance fails, the secondary or passive appliance takes over. Beyond role-based access control, most organizations also require an efficient and flexible way to grant privileged users temporary permissions needed to perform infrequent job duties and to have greater control over the use of powerful privileges by users who need those privileges to do their daily jobs. Because the VMware platform does not provide a viable way to enable approval of a specific operation or operations attempted by a specific privileged user, organizations have turned to Cloud Control's secondary approval workflows for both vSphere and NSX operations. As mentioned previously, this feature allows authorized users to configure Cloud Control to require additional approval before privileged users can perform sensitive or disruptive operations on specific virtual objects, such as deleting or powering off a virtual machine, edit a firewall, or create an edge services gateway. The process requires a designated group of approvers to authorize an operation attempted by a privileged user before that operation can proceed. The workflow is efficient and straightforward. It begins when a privileged user attempts an operation requiring secondary approval per the organization's security policy. Cloud Control blocks execution and informs the privileged user that a secondary approval has been requested for the operation. Cloud Control simultaneously alerts an approver group that a request requires review and provides the details of the request. Once the approver makes the decision, Cloud Control notifies the privileged user. If the request is approved, it gives the privileged user an approver-defined window of time to execute the approved operation. If the request is denied, the user is notified of the denial. If a privileged user attempts any operation that is considered safe to perform without secondary approval, then the operation proceeds without restriction. Auditing and compliance are the bane of many CISOs and IT organizations globally. To date, some tools help cite deficiencies but do not extend the automation of putting an environment back into a state of continuous compliance. This Cloud Control capability provides a rapid payback by ensuring that systems are always compliant, thereby allowing an organization to deploy staff to work on higher value tasks instead of regularly ensuring the environment meets regulatory or internal security audit requirements. The ease with which an administrator can migrate a VM and make changes to the underlying infrastructure makes it challenging to maintain security and compliance for a VMware environment. The complexity of virtual environments also doesn't help. This is why it makes sense to automate security compliance and remediation. Cloud Control's configuration and compliance capabilities support customers by consistently enforcing security controls through a 4-phase approach. The first step is to define a security compliance standard which best meets your organization's needs. This can be accomplished using built-in templates for various regulatory and government standards such as PCI DSS, HIPAA, NIST 853, and industry best practice guidelines such as the VMware Hardening Guide. Once you have defined the standard and created a configuration template, you can manually or on a scheduled basis assess the VMware infrastructure and receive a report to determine a level of compliance. Assessing the environment is only half the task of meeting your compliance goals. Entrust Cloud Control can also perform automated or manual remediation to bring the virtual environment automatically back into compliance. VMware virtual environments are somewhat like growing children. They are constantly changing, and so are security best practices. Luckily, Cloud Control security configuration templates are updated regularly to reflect the latest industry standards. The built-in templates can be updated out of band from the regular product release cycle, thereby allowing you to continually refine your security standards to reflect changes in your security posture. At this point, I'm going to switch gears and run through a quick demo to show how the role-based access control and security compliance and configuration features work through the Cloud Control Transparent Proxy. As you can see, I'm logged in the Virtual Center here, and I'm actually logged in using the published IP address or the proxy IP address for the Virtual Center. And unless you didn't have any idea this was a demo for Cloud Control, you'd think that this was the regular Virtual Center. One easy way to figure out that it's a different Virtual Center is looking at the URL bar. Normally it would be vcenter.deeb.local, which is the name of my local home lab domain. But in this instance, I've used vcenter-pip. So the Virtual Center admin has access to all the normal folders for VMs, and you can see I have the domain controller actually highlighted here. But it turns out I've restricted this Virtual Center admin to not be able to access the console of a virtual machine. In this instance, the Active Directory domain controller. I went to Virtual Center admin to be able to do certain operations to this, which would be their normal job duties, but their normal job duty is not to administer a domain controller. So therefore, I don't want them to have access to the console and be able to get around what they normally wouldn't be able to do with their normal credentials. So if I click on the console here to try and gain access to it, you'll see that the role-based access controls that I've set up for the Virtual Center admin does not allow them to gain access to the console inside the virtual machine. If I switch over to Cloud Control, we'll quickly see here's the warning that says I tried to access the console. I was denied this access, and gives me more details about the operation that was happening, which trust manifest or policy in this instance was being utilized. So role-based access control did exactly the job that I needed it to do. If I switch over to the other view, where I've logged in with the Active Directory domain controller, or the Active Directory domain user, whose normal job is to maintain and work with Active Directory domain controllers, you'll see that their view is very different. When we had the Virtual Center admin logged in, they had a whole bunch of other VMs and folders they could see. Well, what we've utilized is not only role-based access control, but a feature I didn't mention in the previous slides is attribute-based access control. And one of the attributes I've defined is a tag that's assigned to this Active Directory folder and the virtual machine. I've set a tag such that when the Active Directory domain controller or Active Directory domain user logs into the Virtual Center to manage the virtual machine and wants to gain access to the console, they only see the domain controllers. In this instance, in my lab, it's only a single domain controller, but I think you get the point. If I click on the console, we'll now see this is something that a domain administrator would normally need to do. They now have access to there. So this is very different from what we saw when we had the Virtual Center admin log in and try and do an operation. And if I were to go into Cloud Control, we would see that that operation went through, get all the details, and the audit logging that I talked about. Now, I also want to show secondary approvals. So under normal circumstances, powering off a virtual machine is an operation that you might want to do on a regular basis, especially if you're in a non-production environment. But in this instance, this happens to be a production environment. So I want to make sure that a secondary approval operation or workflow is set up such that if someone were to go and power off a domain controller, then that process or that operation would need to be approved by a secondary approval administrator. So if I go to move my mouse and try to power off this virtual machine, when I click yes, we'll see that I now get an operation denied because of secondary approval request. So what ended up happening is an email was sent off to a secondary approver, and they can come into Cloud Control, and we'll have them log in. And once logged in, we can see, oh, there's a pending request for myself. So let me click the View Request Now. It automatically takes me over to the secondary approval location where I can see that the AD admin, which is the requester, attempted to power off a virtual machine. Well, as I mentioned in the role-based access controls, we set up a secondary approval that forces this to either be denied or approved. In this instance, I'm going to deny it because this is normal business hours for me. So I don't want to allow that operation to proceed. So I'll send a little message, hit deny, and what ends up happening is the AD administrator who was trying to power off that virtual machine now got an email in their inbox stating that they're not approved to do this. This quickly shows the role-based access controls and attribute-based access controls, which I didn't mention in the slides previously, on how Cloud Control can help add these additional layers around your VMware infrastructure and lock it down a little bit further. Next, I want to give you a brief demo on how the compliance and configuration hardening features work in Cloud Control. If I switch over to Security and select Configuration Hardening, I can see that I've got two options. I've got policies and templates. Let's start with templates, and you'll see I've got several templates in here. We also have templates for things such as AWS or Kubernetes, because we can also apply configuration hardening templates to those environments. But what we're going to focus on today is ESXi. I've got a few down here. You'll see check marks. These are check marks meaning that the templates are already in use in a policy. Once I've defined that policy or that template, I can switch over to the template view. And we're going to run my assessment only policy. And before I do that, let me look into here and show you how this all ultimately works. Click on the template view. We'll see which template I am actually using to assess the environment. I'm going to assess 3 ESX hosts. There's the name of the template. I've assigned it, and in this instance, I'm using tags, policy tags inside Cloud Control, with a configuration hardening name and a value of assess only. I could also use direct assignments to individual ESX hosts, but in this instance I use tags because it's easier for me to remember. And it also picks up any new ESX hosts that come in that have that tag assigned to them. And then I also am scheduling this to run every day at 7 a.m. in the morning. But for now, it's run it once already today. Let's run it again manually and see what the output is. We'll let this finish. Okay, we see the last event is just a couple minutes ago. Let me click on the last event. Let's view the actual results. This was applied to my ESX1 host where the SSH service is actually running on the appliance. So if I scroll down, we'll see this assessment template failed because I was supposed to have SSH disabled on the host. Well, in this instance, it's actually enabled. So let's go utilize the remediation capabilities of Cloud Control configuration hardening. I'm going to switch over. The remediation policy can be assigned just like it was for an assessment policy. And I'm going to just select it. And we're going to run this. And what we will see is when I run it, we're going to have the option where it's going to not show an X for failing of disabled SSH, but it's going to show a positive result for SSH actually being disabled. So that ran. Let's click on the results. And we'll see it ran against my ESX1 host. If I scroll down some more, we'll see that now we've got a pass for disable SSH. This shows that the remediation can be automated and enables you to not have to spend a lot of manual time or an entire team to maintain compliance, security compliance in your organization. To wrap up, a strong password is a crucial defense to protecting digital identities. Entrust Identity as a Service helps remove the friction caused by passwords and uses the power of the underlying public key infrastructure to strengthen the security posture. Cloud Control Transparent Proxy seamlessly intercepts, monitors, enforces, and logs all privileged user requests, thereby ensuring when the security team or auditor comes around, you can answer their tough questions. Using high-trust role-based and attribute-based access control, enterprises can vastly limit any damage that may result from the breach or escalation of privilege by insider threats. Enabling secondary approval on all critical administrative actions, such as the admin's ability to power off or delete a virtual machine, you can be assured that accidental mistakes are greatly reduced. Using high-trust compliance assessment and remediation, an enterprise can be assured that its infrastructure is always in a compliant state and aligns with its compliance and security hardening standards. Thank you.